Superheroes are amazing. They can do things that we can only dream of, like bench press a school bus full of children, or run from Australia to Zimbabwe in the blink of an eye, or go from public figure number 1 to unrecognizable with just a pair of glasses. But it's not their action-packed stories of loss and redemption that compel us about these characters. It's the physics. Duh. Now, it's no secret that comic books tend to bend the rules of physics every once in a while, but to what extent? What should happen to Flash if he were to go supersonic? Right off the bat, we run into a pretty major problem with the rate of acceleration. The Flash can go from 0 to light speed basically instantaneously, but in the real world, once a human body of about average weight reaches an acceleration or deceleration of about 100 g-forces, our bodies start to fall apart. It's the equivalent of going from rest to 70 miles per hour in just a span of half a meter. The Flash is obviously able to withstand accelerations like this, but if he were to, say, save a damsel in distress from a falling chunk of rubble, the damsel would probably turn to filet mignon in his arms from the sheer force of acceleration alone. Now, the second problem comes with a little thing called adiabatic compression. When something moves really fast, like when a shuttle enters the Earth's atmosphere, or when the Flash laps the planet in less than a second, it compresses a plug of air directly in front of the object and creates a sort of vortex in which no energy can escape. The faster the speed, the more energy is generated, and the hotter the system gets. In the same way that a shuttle burns up when it enters the atmosphere, a human going at Flash-level speeds would, well, vaporize. What about super strength? Maybe we couldn't run at the speed of light without a few kinks in the road, but would physics allow us to bench press a building or punch through a steel door? Kind of. It comes down to Newton's third law of motion. Every time we apply a force to an object, that force is applied directly back onto us in equal amounts. Say, for instance, you used your super strength and applied a force of 10,000 newtons to a brick wall. Per the third law, 10,000 newtons would also be applied directly back onto your fist and destroy every bone in your hand. So, not ideal. But say you were Clark Kent, man of steel with unbreakable fists and gorgeous, gorgeous hair. Would you be able to, say, stop a crashing airplane mid-dive with your bare hands? Pressure is equal to force divided by area. And in the case of super strength, we have a lot of force being applied to the small area of a person's palm. This is fine if you're trying to break through an object like a vault, but if you wanted to stop a massive falling object like an airplane, you would end up going directly through it and killing everyone inside. But at least you'd have an airplane donut. So, priorities, I guess. Congrats! You made it to the end of the video. Thank you so much for watching. I hope you learned something new and had fun doing it.